5.8, the law of cosines. To use the law of sines, we need to already know a side and its opposite angle, right? So if I have A over sine A equals B over sine B, in order to solve this, I need 3 of these 4 pieces of information, which means that I need at least one pair of a side and its opposite angles. What if we know 2 sides and the angle between them, or 2 angles and the side between them, but we don't know a side and the opposite angle? Then we use the law of cosines. The law of cosines looks really nasty, but it's not that bad. It's derived from the Pythagorean theorem, and you can look at this section 5.8 in your book for a proof if you want to. So again, we have some triangle with angles A, B, C, and opposite sides, A, B, and C, respectively. And then we can do any version of these. A squared equals B squared plus C squared minus 2BC cosine A. B squared equals A squared plus C squared minus 2AC cosine B. C squared equals A squared plus B squared minus 2AB cosine C. So the thing is that the side at the beginning that's all alone by the equal sign is the angle that's at the end in the cosine. And then these two, B and C, are the same, or A and C, or A and B. All right, so for a right-handed golfer, a slice is a shot that curves to the right of its intended path, and a hook curves off to the left. Suppose Sayri Pak hits the ball from the 7th tee at the U.S. Women's Open. The shot is a 160-yard slice, 4 degrees from the path straight to the cup. If the tee is 177 yards from the cup, how far does the ball lie from the cup? So here's a drawing. We have 177 yards from the tee to the cup. The golfer hits the ball 160 yards. We want to find this missing side of the triangle, given that we know one angle. So here we are solving for the side opposite the angle, right? So we're solving for the C, because cosine, the 4 degrees goes in the cosine. So we're solving for C. So C squared equals 160 squared plus 177 squared minus 2 times 160 times 177 cosine of 4. And you plug all of that into your calculator, and you're going to get that C squared equals 426.97. But remember that that's C squared, so we need to take the square root of that, and that's going to be 20.66 yards. And that's it. It's literally that easy. You just plug it into the formula. Okay? In order to solve a triangle, we can combine the law of sines and the law of cosines. So here we've got some triangle A, B, C. And we know angle A is 120 degrees, side B is 9, side C is 5. So what we can do is we can solve for this missing side A. So A squared equals 5 squared plus 9 squared minus 2 times 5 times 9 times cosine 120. And you plug all that into your calculator, and this ends up being 106 minus 90 cosine 120, which is 151. And you square root both sides, and you're going to get that A equals the square root of 151, which is about 12.3. So now I know all 3 sides of this triangle. and I know one angle, but now I have a side and opposite angle pair, and that means that I can use the law of sines. The law of sines is a little bit less work. So if I want to solve for angle B, now I'm going to use the law of sines. Sine B over the opposite side 9 is equal to sine 120 over the opposite side of 12.3. And I multiply both sides by 9 to get rid of that denominator. So I'm going to get that sine B equals 9 sine 120 over 12.3. But that's only going to give me the sine of B. I need the inverse sine of B. And if I do that, sine 120 over 12.3, that gives me 0.634. I'm going to get sine B equals 0.634. Now, in order to find B, I use the inverse sine, which is going to be 39.32 degrees. And now, once I know two angles, I can just subtract from 180, right? So 180 equals 120 plus 39.32 plus C, and solve for C. And C is going to be 20.68 degrees. So I found A, I found angle B, I found side C. I have all three parts of this triangle, which means that I have solved it. Well, I have all six parts of this triangle, which means that I have solved it. Go me! All right, here's another one. We have three sides of a triangle. So A, B, and C. On side A is 24, and side B is 40, and side C is 18. We want to find an angle. Let's use the, it doesn't matter which angle we want to find. Let's start with A. So we want to find angle A, and so that's going to be 24 squared equals 18 squared plus 40 squared minus 2 times 18 times 40 cosine of A. And so that gets us 576 equals 1924 minus 1440 cosine A. Subtract 1924 from both sides. Negative 1348 equals negative 1440 cosine A. And just to remind y'all, on our unit circle, angles that are between 90 and 180 degrees have a negative cosine. So if you do get that your cosine A is a negative number, that's okay. There's nothing wrong with that. And I believe if we did this for B, you would get that cosine B equals some negative number. And that's okay. That just means that you're looking at an obtuse angle. But in this case, our negatives cancel out. So we're going to get that cosine A equals 1348 over 1440. And so we can use the inverse cosine and just plug that fraction right in there. And we're going to get that angle A equals 20.6 degrees. Now we could either do the law of cosines again on one of these angles, or we could do the law of sines. Up to you. If you love doing law of cosines, go ahead and do that. I'm going to go ahead and do the law of sines. If you're going to do the law of sines, pick the side angle pair with the smallest side in order to avoid creating that ambiguous case of law of sines. So B, because this is a bigger side, could be that ambiguous case. Or could be, it's not really ambiguous, but you could get an angle that is greater than 90 degrees. And when you do this, actually B is an obtuse angle. So just to avoid any confusion, start with the smallest one. And so now I can use the A that I already have. I'm solving for, so sine C over 18 equals sine 20.6 over 24. So I'm going to multiply both sides by 18 to get rid of that. Sine C equals 18 sine 20.6 over 24. And when we do that, sine 20.6 over 24, that ends up being about 0.264. And so we do C equals the inverse sine of that. And you're going to get that C is 15.3 degrees. And then we can solve for B by doing our 180 equals 20.6 plus 15.3 plus B. And when you add all that up and solve for B, you're going to get that B is 124.1 degrees. So, if you did the law of sines to solve for B, you would have to check your flowchart, and you would see that with this combination of sides and angles, you're going to get one, you only get one solution, but it's an obtuse angle. So instead of taking the answer that you would get when you did the inverse sine, you would have to then subtract that from 180. So slightly less work if we just do the smaller one here. It would have been even less work if I had done B into my law of cosines, and then I wouldn't have had to worry about it at all. But hindsight's 2020. If you know the measures of three sides of a triangle, you can find the area of the triangle by using the law of cosines and the formula 1/2 BC sine A. So if we use this and we substitute some stuff in, so we can use this to, if you know three sides, you can use the law of cosines to find one of the angles, and then you can do 1/2 BC sine A. So here we've got a triangle, A, B, C, where A is 4, B is 7, B should be this one, B is 7, and C is 9. And so we need an angle, any angle, doesn't matter. I'm going to solve for angle A. And so we're going to use the law of cosines. And so that's going to be 4 squared equals 9 squared plus 7 squared minus 2 times 9 times 7 cosine A, which is 16 equals 130 minus 126 cosine A, which means that cosine A equals negative 114 over 126, or negative 126. So A is going to be the inverse cosine of 114 over 126, which ends up being 25.2 degrees. Now we know an angle. We can do the area equals 1/2 BC sine A. So 1/2, B is 7, C is 9, sine of 25.2, and you plug all that into your calculator, and you get an area of 13.4 square units. There's also Hero's formula, kind of handy. If you know the measures of 3 sides of any triangle, you can find the area using this, which doesn't involve any trig. I assume it's derived somehow from Pythagorean theorem, but I don't know exactly. Probably a proof in your book. So you find S as 1/2 of A plus B plus C, and then your area is the square root of S times S minus A times S minus B times S minus C. Right, so use Hero's formula here to find for this triangle. S is going to be 1/2 of 72 plus 72 plus 83 plus 95, which ends up being 125. And then the area is going to be the square root of 125, 125 minus 72, 125 minus 83, 125 minus 95, which is 125 times 53 times 42 times 30, and then you take the square root of that and plug that into your calculator, and that's 2,889.2 square centimeters. Lots of formulas, but I will give you all the formulas on your quiz. You just have to know how to use them.